Exercise A01 is going to have us develop an abstract data type, a linked list of integer, which is going to allow us to implement some of the basic functionality that you have on a typical linked list of integer, as illustrated by the code examples in the textbook. So you can see here in the description of the exercise that we are going to have several files to span this linked list, integer linked list, abstract data type. All of those files actually are given to you. So refer back to the instruction given to you by your instructor. Okay, you will find yourself in possession of a linky. That's the name of our linked list implementation. Linky.h, which contains the header of all the function and the definition of the data structure. Linky.c, which contains part of the definition of the function listed in the header, only a subset of them, typically the ones that are the most straightforward to implement. And then we'll have two files, linkly_iterative, linkly_recursive, which are going to both contain definition, implementation of the same functions. Okay, all the other function left from the header file that were not implemented in linky.c. So the purpose of linkly_iterative and linkly_recursive is to allow you to implement both an iterative and a recursive version of all of those functions and be able to compare one to another. The file test.c will contain actually a main function with a bunch of calls to all the functions that are mentioned and defined and declared in all the previous files, just for the purpose of testing them. This is an interactive testing insofar that the test.c main function will simply display on the screen the result and the content of the linked list after multiple operation, and you'll have to visually check that it does what it is intended to do. So to be more specific, let's have a look at the files that you are going to be given, and let's start by the test.c. As you can see, this is the content of test.c. As you can see, we are going to use the data type create, which we called a T-cell type cell of information. You could have called it T-node, whatever you want. We have a pointer here on T-cell, which is going to be the head of our list. And we have a pointer on pointer P, which we are going to use later to simplify our notation. We start by creating here one element of a list, okay? And then we call T-cell display, one of the multiple functions we are going to define, and we display the content of the list. So this list will contain at this point only element 0. And then we are going to comment on the screen, display something that say we are adding to the tail of the list the value 1, do it, and we'll come back on the syntax after, display the new content of the cell. And we are going to keep doing that, announce what we are doing, do it, display the content of the whole list on the screen so that you can double check that what we promised was going to be achieved has been indeed achieved. Let's have a look at a terminal here, and we are going to run one of the two executable that was given to you with the rest of the file. So we have an executable called iterative.exe and one called recursive.exe. Let's run iterative.exe. This is what, when we're done with our linked list implementation, what our program should be able to do. Here's the initial linked list, contains only 0. Add to the tail the value 1. Here is 1 being added to the tail, then 2, then 3. Then add to the front the value -1, then add to the front -2, -3, and you see how the list expands here. Then del the tail value, which was 3, it's gone, 2, 1. Then del from the front, delete from the front a value, the -3 is done, it's gone, sorry. Then -2, then -1, and we are back to our initial list. So this is what we want to achieve. Of course, if we run the iterative version or the recursive function, we obtain the same outcome because both linky_iterative.c and linky recursive.c implement actually the same functionalities, just with different programming styles. So let's have a look at the files that we have here in our initial package. We have already commented on test.c. I'm going to go over some of the important other files. We have linky.h. Linky.h is going to be our main header file. So as I already announced, it's going to contain the definition of the data structure, and then it's going to contain the header of all the functions. Okay, 2 words real quick about this file. We have a struct s cell. The s is just a convention to remind you that this is the name of the structure here, and that every time you see s cell, you should have a struct keyword in front of it. This is what the s reminds you. Struct s cell. It's one convention, like you would have many other. Inside the struct s cell, we have data of type int, and we have next of type TP cell. What is a TP cell? It's type deft here. A TP cell is a struct s cell star. So there we go. We have our typical linked list data structure here with some data and a pointer to the next element. Then we do a type def here, by which a struct s cell become a t cell. So now we can use t cell everywhere to refer to struct s cell. Here are the couple of functions we're going to implement to start off with. Okay, t cell create, give me an int, and I return to you the address of the newly allocated t cell data structure containing this int, and for which the field next is set to null. Okay. T cell display, give me a pointer on T cell, and I will display the entire list pointed to by star list. Okay. T cell add front, same convention. We are going to use the same first parameter here for all of our T cell function. And the idea here is uniformity, so that every time you call one of those functions, you don't have to wonder if you should pass a pointer on T cell or a pointer on T cell. So all of those functions, T cell add front, T cell add tail, T cell del front, T cell del tail, are going to take as first parameter a pointer on the pointer of the first element of the list, which will allow us very conveniently to modify the pointer to the first element of the list if we need to. For example, removing the last element of the list that had only one element. The second parameter for add functions like add front and add tail will be a pointer to a new element that you have allocated, for example, using tcell create. And the rest here is pretty much self-explanatory. So we have our header. We already talked about test.c. Let's have a look at linky.c, which contains the implementation of our, between quotes, easy function. Tcell create, you can see there is an empty function there. Tcell add front, tcell del front. None of those functions requires you actually to use a loop or to use recursion. In linky underscore iterative, you will find the function that will be a little bit more complicated. Tcell display, followed by tcell add tail, followed by tcell del tail, which are going to require you to iterate over the elements in your linked list before to find the last one and add something after it, or delete the last one, or simply iterate over all elements and display everything in the list. Let's go back to the list of files here real quick. What do we have left? Well, linky iterative is for you to develop an iterative version of that function, and these are the same function in the file linky recursive, where you're going to be able to develop a recursive version of those functions. When you want to compile your project, we're going to do that in 1 second. When you want to compile your project, you will have to compile, of course, test.c, which contains the main, linky.c, which contains some of the function of this linked list abstract data type, and then you will have also to compile either linky iterative.c, and if you do that, you'll have an a.out, which is using the iterative version of some of the function, or you will compile linky recursive, and you will get an a.out that is going to use the recursive implementation. In both cases here, our functions are empty. So here's what's going to happen when you first run your test. Okay, initial list, well, I call display, but that function does nothing. So no list is displayed. Then I call add tail, function does nothing. No list is displayed when I call tcell display afterwards. So really, the basic testing here is going to be really quite empty, and then progressively we will add to it, okay, as we implement one function after the other.